In this lesson, we're going to review what chemistry is and what matter is. So chemistry is a study of matter, energy, and the interactions that happen between them. Let's take a look at what matter is to fully understand the definition of chemistry. Matter is anything that has a mass and a volume. So examples of matter could be water, oxygen that you breathe in, a desk, your matter, I'm matter, a pencil, a pen. As I mentioned, the various gases in the atmosphere, oxygen counts as that as well. So for something to be considered matter, as I mentioned, it needs to have a mass and a volume. The mass, by definition, is just a measure of the quantity of matter that's there. Usually we measure it in terms of grams or kilograms, and there's other units you can use for mass. Um, and the volume is a measure of how much space that object takes up or occupies. So, for example, I have a water bottle and it can hold 500 milliliters of water. And so those are some different units of volume. We have liters, milliliters, cubic centimeters, for example. Those are just different units that we can use to measure how much space an object actually takes up. And one more thing I want to mention about matter is that energy is not matter. In reality, the universe is made up of really two things, matter and energy. So if we have our universe here, universe, we have matter and energy. And so we're focusing on matter right now. And again, matter is anything that has a mass and volume, takes up space. Energy does not have a mass, and energy does not take up space. For example, when energy is transferred from a hot substance to a cold substance, that's energy, that's not matter. So when you say cold, that's not matter. When you say hot, that's not matter either. There's a transfer of energy that happens between hot and cold objects. Light is a form of energy as well, but is not a form of matter. Light does not have mass, and it does not occupy space. So these are some examples of matter as we mentioned previously. Let's take a look at our definitions of matter and volume and mass. So if we were looking at these examples of matter here, a bowling ball and this beach ball over here, we could ask which one has the larger volume. Well, as you can see here, this beach ball over here has the larger volume. It occupies more space than the bowling ball. But which one has a larger mass? Even though this beach ball occupies more space, this bowling ball here does have a higher mass. So it does have a lower volume, but a higher mass. And this one here is a higher volume, but a lower mass. So essentially you have more space taken up by the beach ball, less space taken up by the bowling ball, but higher mass for the bowling ball, and lower mass for the beach ball. So one thing that chemistry likes to do is it likes to explain the behavior of matter. And to explain how matter behaves, we use this theory called the particle theory of matter. And we're going to go over what those points are. And when I say behavior, I mean for any question you might ask about matter you're studying. So why does water flow faster than maple syrup, for example? So we're going to use the particle theory of matter to explain why water would flow faster than maple syrup. Or why is it that when you leave when there's a puddle of water on the ground, a few hours later, or a day later, that puddle is now gone. Where did it go? What happened to it? We can use a particle theory of matter to explain that. So there are four main points to our particle theory of matter, and you can remember it using this memory aid, a mnemonic, PSAM. And we're going to go over what those 4 points in the particle theory of matter are. The first one, P, is that all matter is composed of very, very tiny objects called particles. P for particles. So anything that's matter is made up of little particles. And what we're going to learn later on is the tiniest of those particles are called atoms. And we're going to focus on that and review that in another lesson. Just understand that those particles are so small that we can't see them. So they are too small to be seen. The other part of the particle theory of matter is that all particles have spaces between them, S for spaces, so spaces between them. And the amount of space between the different types of matter varies. So for example, if you're looking at a solid piece of matter, the particles are very, very close together. It looks like there's no space, but there is. They're just very close together. Um, if you look at, let's say, gases, you'll notice that the space between the gas particles is much larger than we saw for the solid particles. And then if you look at the liquid over here, you'll notice it's somewhere in between the solid and the gas distance. So solid, the particles are very, very close together. Gas, the particles are very far apart. And liquid, in between that of solid and gas, somewhere in between. Our next point for the particle theory of matter is that particles in a substance attract each other. A for attract. And again, that attraction varies depending on the state of matter that you're in. So in a solid, for example, here we have ice. The particles are very, very close together. And the attraction between the particles is very strong. So it'd be hard to put your hand through ice because the particles are close together and the attraction between them is very, very strong. But if you look over here, we have liquid. And so this is liquid water. You can swim in liquid water. You can raise your hand out of the water, put it back in the water, your hand can go through it. And that's because, yes, the particles are close together, but they're not as close together as they are in a solid. And also the attraction is not as strong as they are in a solid as well. So weaker attraction in the liquid compared to the solid, and that's why you can swim, for example, in liquid water, but not in the solid water. And then we go to gases. So with gases, you can see we walk in air with ease, we run in air with ease. The attraction between the particles is not as strong as that you would see in a liquid. So it's very easy to walk through air, but we'd feel more resistance going in the water because that attraction between the particles is a lot weaker in the air compared to the water. So in order of strength, going from strongest to weakest attraction, solids have the strongest attraction. Liquids would be next in terms of that, and then gases would be the weakest attraction between the particles. And then we get to the fourth point of the particle theory of matter, and that is that particles that are present in matter are always in motion. M for motion. They're always moving. So it doesn't matter if you're solid, liquid, or gas, particles are always moving. In a solid, the particles are very close together and their motion is more of a vibrational motion. So they kind of stay in one spot, but they're vibrating in that one spot in a fixed position. In a liquid, you have particles that are not just vibrating, but also sliding past each other. They're sliding past each other. So there's more motion there. And then finally, there's even more motion when we get to gases. So gases, you have there's vibrating, they're sliding past each other, they're spinning around in all these different directions. It's more of a random motion compared to the other states of matter. So solids, they do move, remember that, but they vibrate in a fixed position. Liquids, in addition to that, there's also sliding past each other, and gases are essentially far apart, moving in all different random directions.